So in today's tutorial, we are going to try and model a potentially more exciting situation. So this will be a three-dimensional solid model. We will actually create the geometry and also a large portion of the definitions like curves, nodal sets, boundary conditions, and so on and so forth through LS-PrePost. What I have here is a schematic overview of the model. So if I want to be specific, we have this cylinder with these dimensions that I'm showing here, 12 inches tall, a diameter of 6 inches. It's made of concrete with an elastic modulus of 5000 ksi, a Poisson's ratio of 0.18. And we also have a compressive strength of 5 ksi, and also this epsilon naught parameter means what is the compressive strain at which the material hits that compressive strength of 5 ksi, which is, this compressive strain is about 0.25%. It's actually exactly 0.25%. So this cylinder is actually placed in between two steel plates. Each of these plates is 2 inches thick, and they are made of linearly elastic steel, having an elastic modulus of 29,000 ksi and a Poisson's ratio of 0.3. And these plates have a square, let's say, plan configuration with a dimension equal to 9 inches. So what this model will be loaded with is we will be applying a monotonically increasing downward displacement up to a value of 0.2 inches at the top face of the top plate, while the bottom face of the bottom plate, the base of the entire model if you prefer, is fully fixed against any translation. So without further ado, what I'm going to do is open LS-PrePost. So I'm here in my desktop of my computer. I'm opening once again the FEMultiPhys builder dialog here, and you can actually go to model and find run LS-PrePost. So I'm going to left click on run LS-PrePost, and this should bring forth and open the LS-PrePost executable. This is the particular version that I have installed on my machine. It's version 4.13.2. It's a 2025 version, which is a fairly recent one. And what I want to mention is, if this is the first time you are using LS-PrePost, this won't be what you will be observing on your end. I have made some changes. I've made the background to be white color. You should be seeing a more gradient bluish background. So let me first of all align what I'm seeing with what users who have opened PrePost for the first time should be seeing on their end. To do this, I have to go to settings and find this option, configuration settings. Left click on it, and then in the resulting window where you have various options related to view configuration, all I have to do is click this button, reset configuration button. So if I click on that, I see this verification dialog. I click on yes, and lo and behold, I should now be seeing what a first-time user of LS-PrePost might be seeing. Again, because I don't like this very much, I prefer to have a single color background, and most of the time I prefer to have a black color background so that my eyes don't get very tired. Anyway, I'm going to show some capabilities that we have in this regard. By the way, the main options that you have to use in LS-PrePost actually are included in this file menu, where we will see various options to open and also save when we post-process. Save, let's say, image files or print image files or even create video files with animations. And then all the action is on these toolboxes on the rightmost column, rightmost edge, let's say, of the viewport here. I've already maximized the window of LS-PrePost, as you can see on my screen. And what I want to mention is this first group of these 5 buttons which are related to geometry is always, it's always there, and you can invoke directly commands related to this. And then we also have these additional buttons which activate different groups of commands. So we have this button here which says element and mesh. So if I click on this button, I should see an additional column which has to do with various options that we can use to create a mesh, discretize a geometric entity, or even create a mesh manually, defining individual coordinates of individual nodes, then defining connectivity of individual elements, and so on and so forth. This button here is model and part, where if you click, you basically have the option to create and manipulate different parts, different sections basically. Each part in FEMultiPhys corresponds to a different section assignment in FEMultiPhys. And you also have the capability to create other entities. We will again see which buttons of these options become relevant. Then we have this button here which says Element Tools. If you click here, these have to do with editing nodes, editing elements, or even deleting nodes and elements. And then this final button which says Post is for post-processing. It will only interest us when it comes to loading the output after we conduct the analysis. So we will be using LS-PrePost both for pre and post processing this particular model. So first of all, I want to go back to this model and part button, because what I will be looking here among the various options is this part color option. This is the option that allows us to define the color assignments for any entity in a particular model, or even for the viewport itself. So if you click here the part color option, and you may notice the general idea is after you create different parts and you see the finite element mesh with the various parts, each part will have a different color assigned by default from the app, but then you can change the color simply by picking a color or giving the red, green, blue quantities between 0 and 255 here. Okay, and then after you define the color you want, you just left click once on the part that you want to be assigned this color. All I want to do now is assign a particular white color to my background. So once I select this white color, all I have to do is go here and click this button, the back G button, which also, if I hover above it, you may notice it was saying apply selected color as plain background color. So I click on here and I see nothing changed. Why so? Let me click on Done. What happens is if you go to the View menu, which also is the obvious choice if you are trying to mess up with the viewport and the color definitions, you may find this option here, the background option. The background by default is a bicolor fade configuration. So the idea is we have a bottom color which is slightly lighter, if you may be noticing, and gradually it fades to a different color as we go from bottom to top of the screen. To activate the single color definition that we assigned, we have to activate this plain option. And lo and behold, this is our plain white background. I will go back to the part color menu here, because I also want to assign a black color. And mind you, there is no perfect black preset here. So I have to select 0 values for all three, red, green, and blue values here. And then all you have to do is click on text and then label. So this makes sure that any text that appears on the screen should have black color so that it contrasts properly with the background. I think by default the text color in FEMultiPhys is white, and of course if you change the background into white as well, this means some kind of trouble, you won't be able to discern the text. So let me click on Done. And what I'm going to do next is draw the geometry of the cylinder. So I'll try to showcase various options that you can leverage when defining a model in LS-PrePost. And again, if you go on these top 5 buttons, these are the ones that have to do with geometric configuration. So we have something called reference geometry, something called curve, something called surface, and something called solid, which probably, as you may understand, is what we should be looking for. So if I left click on this solid, I should be seeing the various solid preset commands that I have available through LS-PrePost. You may be guessing already from these particular buttons that it's this button we are looking for, the cylinder one. So if I left click on it, I see this create cylinder prompt, which allows us to define various definitions. Notice in FEMultiPhys by default, a cylinder thus created, it has its axis aligned with the Z coordinate axis, and then of course the section of the cylinder lies in the XY plane. So we don't have to play with this. We should be able to give, you know, there are other ways to give, let's say, define the axis of the cylinder as, you know, the vector that connects 2 points in space if you want to get a cylinder that doesn't have its axis aligned with the z-axis. But right here, you know, although I encourage you to experiment, that's not of interest in this particular um, tutorial. So I'm just going to move along with this particular preset. So the radius of our cylinder should be equal to 3 inches, as you may remember. We want our diameter to be 6 inches. And then the start position is at 0, meaning at z equals 0. The top position is at z equals 3 now. And there are two ways to set the end position at 12 so that we get a height of 12. You can either highlight, input this text and give 12, or you can go here at this top entry. You may notice these up and down arrows. If I keep clicking here, and by the way, if you want to zoom out in LS-PrePost, you can use your mouse wheel, but first hold down the control button in your keyboard. So you may notice that basically, you know, by clicking on this up arrow, the top increases, you know, from 4 to 5 to 6, so it increases by 1 every time. If we click the down button, okay, the top decreases, it gets lower to lower z values, that is. For the time being, let me directly now type the value of end position of 12. The start and end angles are from 0 to 360 so that we get a perfect circular section. And I click on apply, and I should be having my solid cylinder thus created. Now, my next step could be to create the mesh for the solid cylinder, but before I do so, let me also create the geometry for one of my two plates. You may remember these plates had a square shape concentrically placed over the circular cross-section of the cylinder. Okay, so this means we must be at a location of x equals y both equal to -4.5 and for one corner of the square section. The other corner must be at x and y both equal to +4.5, and then we have to give a height, a thickness along the z-axis equal to 2 inches for the bottom plate. So let me close first of all the drawing cylinder menu, and I'm going to also draw one of the two plates through this solid box command that I see here. So I'm going to draw the bottom plate. So I go to box command, left click here, and again you have different options for, you know, creating a box. You may be seeing the preset for the box again where you can play with the arrows. I won't do it this way. Instead, I'll directly give the coordinates of the two opposite corners of the box-shaped solid that I want to create. So I have to give x1, y1, z1 coordinates for the first corner point, then x2, y2, z2 coordinates for the, let's say, opposite diagonally from the diagonal perspective point. Now again, x1 and y1 should be both equal to -4.5 inches. Okay, z1, the lowest z value basically, I should set it equal to -2 inches so that the bottom face of my box-shaped solid plate is, you know, 2 inches below the bottom face of the cylinder. The cylinder bottom face was by default at z equals 0. Then x2 is at +4.5, y2 is at +4.5, and then z2 should be equal to, should be set equal to 0. And if I click on apply, I should be able to see a preset of this particular geometry. And then I can click on close. And you can even play with the view. I mean, the view buttons and also other options on how you want the mesh and everything to show up are at this bottom bar here of the viewport. So you have various options. This, if you click here, this is auto center zoom, where it automatically zooms so that we can see the entire model. We have this option to zoom in. If you click here, you can basically draw a window and zoom in. You have this option to zoom out to the previous zoom that you had established. Okay, and then you have other options to establish rotation or some preview, preset rather, view angles. For instance, this is the isometric view. in LS-PrePost. If you click this arrow, you can see other presets like top, okay, where if we go to the top view, we can clearly see that the square plan of the plate is indeed concentrically, let's say, placed around the cylinder. Once again, let us go back to the isometric view now for the time being. And you can even rotate the view. So you can, if you right click here, you can select which different axis you want to rotate about. So here I'm rotating about the Z axis by minus 10 degrees. If I right click here, I have the option to give a different value. For instance, I make the minus 10, 10. And then if I keep left clicking, every time I left click, I rotate about the selected axis by the particular amount of 10 degrees here. Let me bring the rotation back to the isometric view. And what I'm going to do next is actually define the parts for the model. To create the parts for the model, you can go in this model and part button, click on it so that you activate the model and part commands, and then this is the option that we will be working with, the part data. If I left click here, you have the option to show or create different parts. Okay, what should be the part type that we want to assign? The first part will be the concrete cylinder. This first part corresponds to the first section in FEMultiPhys language up to this point. The second part will correspond to the second section. And in our model, we want the first part and first section to correspond to the concrete cylinder. The second part or second section will correspond to the steel plates. The part type, if you click here, it should be a solid. And then you can give a part ID or just click at new ID and it populates automatically what is the lowest ID value available at any instant. You can even give a name to your part and then click on accept. And we can create two parts in this fashion. I'm not going to do this right now because it turns out I can automatically generate the mesh, and when you create a mesh through the mesh generation options of LS-PrePost, LS-PrePost by default allows you to assign a new part to every new discretization that you try to establish for a different geometric entity. So the two parts that we need will be automatically defined. We can still come back here and click on modify after we create these parts, so that, for instance, we give them proper names, more descriptive names, so that it's easier for us to discern which part is which. So let me click on done, and what I'm going to do again, if you go in this list of commands, the command we should be looking for is this one, the one that says element and mesh. Let me left click here, and there are various options. Interestingly, this is one we could have used, the shape mesher. What is good about shape mesher is if I left click on it, it allows you to automatically create particular meshes for given entities. That is, you can create a discretization of a box solid with, specific XYZ coordinates for the two, let's call them opposite corners, and then defining the mesh size parameter so that you don't have to draw a geometric solid first and then discretize it. Similar, you can, for instance, discretize a cylinder as a solid, or discretize the surface of a cylinder as a shell assemblage, and so on and so forth. I'm just showcasing this. I'm not going to use it for this particular tutorial, but you are always encouraged to experiment with all these options. Okay, so I'm going to click on done. I'm not using this option. Instead, you can use this auto mesher for two-dimensional meshes, which is not the case here, and then also this solid mesher for three-dimensional solid meshes, which is what we will be using. So let me left click on this solid mesher here, and I'm going to begin by meshing the cylinder. So what you have to do is, first of all, you leave all the options as you see them here. So operation is meshing. You leave the try meshing automatically option. You leave this project option selected, and then make sure you left click on the viewport and highlight with a different color the solid that we want to mesh. Okay? Then, when you are meshing a prismatic solid like this one, it works always best. Sometimes you are unable to mesh unless you give what we call a target surface. That is, the program oftentimes wants you to pick up a planar surface so that we help the grid generator start with the two-dimensional discretization of that surface, then move in the third dimension of the cylinder. So what I'm going to do first of all is give an element size. I'm going to select an element size of 1/2 inch. So this should give us what? We have a height of 12 inches for the cylinder. We should be having a total of 24 elements along the height. This will also be the approximate size inside, in the cross-sectional plane. But of course, the cross-section geometry is a circle, so we don't have nicely shaped, square or quadrilateral elements, as we will see. Anyway, what I'm going to do is highlight this radio button, the target surface radio button, so that we have to pick a target surface for the mesh generator to begin with. And as you may be guessing, the surface I'm going to left click on is the top surface of this cylinder. Okay? We leave everything else as is and then try to mesh. So if I click on mesh, I should be able to see. Okay? And again, if I hold down the control button and then use my mouse wheel, I should be able to zoom in and out. And this looks like, let's call it a fairly reasonable mesh as a first try of sorts. So it looks quite good. One of the neat features of this approach is that if you see a mesh that you don't like and you want to try creating something better by playing with these parameters, you always have the luxury of clicking this reject button. This means this mesh has not yet been registered in the model as the discretization of our cylinder. Now, since this is a mesh that I do like, I'm just going to click the accept button. And from this point on, this mesh has been registered. By the way, you cannot see the discretization yet. The reason is if I go back to this bottom bar, if you go in this left region of the bottom bar, you have options on how to see the mesh. And you can find this option here that says mesh on or off. If you left click on it, you should now be able to see the mesh. If you left click on it again, you can hide your mesh. Okay, it's always good to be able to see the mesh, especially in the pre-processing stages. Now, we are done with meshing, of course, the geometry of the cylinder, so we can click on done. And by the way, you may notice that the mesh discretization for this first part that I have created, if I have this kind of model tree where again, if you expand, you can see this is the first part. We also have the shape group, which is the geometric entities we have created. And you may notice we have active the solid cylinder and solid box that we define. The solid cylinder is no longer necessary, and by the way, when we will eventually save, we will simply save a keyword file for LS-PrePost, which only retains the mesh information, the parts and nodal coordinates and element connectivity, meaning these geometric entities will be lost anyway. Since we don't worry about this solid cylinder, okay, I can click on this checkbox here and hide it from the view, so that I only see the mesh for the cylinder that I have now. I can go back to this button here to auto center the view, right? And what I'm going to do next is discretize the geometry of the bottom plate. And I'm going to use a larger element size of 1 inch for the bottom plate. The bottom plates won't have any regions of, large strain gradients or whatever. They are bound to remain linearly elastic with small strains. So we can get along with a much coarser mesh for this. So what I'm going to do is go back to this solid mesher option. Okay. And I'm going to once again left click now on the solid box that I defined for the bottom plate. I'm going to give an element size of 1, or I can even give 1.0 if you want to be perfectly rigorous. And I don't know if we can mesh automatically. Let me try doing so. Okay, yes, this particular shape was so simple that we were able to mesh automatically. In case you were not able to do so, you could still have tried to, basically give again the target surface and then click, let's say, the top face of this box-shaped plate, and the program would be able to handle the rest of it. By the way, if any error occurs in a process or something unexpected, always be on the lookout for the messages that you may be having here on this bottom message region. So if anything goes wrong, you should see some kind of a warning or error message or whatever here informing you on what might have caused trouble. Now again, I haven't yet registered this mesh, so I could have clicked on reject, but for the time being, this is the mesh that I'm looking for the bottom plate, so I can click on accept. And you may notice now I have a second part, a finite element mesh part 2, which has a different blue color here, and it corresponds to the elements that have been assigned to this plate. Again, if I had a third solid and I tried to mesh, LS-PrePost by default would be trying to assign, let's say, this mesh to a part with ID 3. Let me close here and click on done. Once again, we can hide the solid box. We no longer need it for the bottom plate. We could have drawn a solid box for the top plate as well, then automatically generate a mesh for that top plate. And of course, we would want the top and bottom plates to correspond to the same part ID, because they're made of the same material and everything. What you could have done then is go to this option, again, Element Tools, and find this option here, Move or Copy. What this option does is it allows you to select a part ID, and then let's say we select part with ID 2, and then you can click on elements, or you can actually, you see this select element option which becomes active. You could go to an area and drag a window of elements, and all the elements you would have selected, once you clicked on apply, they would have been moved to this part that you selected here. So this would be a way to move the elements of a part 3 and assign them to the elements of a part 2. Okay, for the time being, all I want to do is edit the name of the parts. So what I'm going to do is go again to this button, the model and part button, activate these commands, and I'm going to this button here, the command to involving the part data, left click on it. And what I'm going to do is I make sure I have the modified radio button activated here, and what I'm going to do is select the part 1, which is named by default as solid 1, and name it cylinder, so that I know this first part corresponds to the concrete cylinder. I can click on accept, and now you should be able to see in your model tree the first part has been renamed as cylinder as well. I can also select the second part, and we can name it plates, and I can click on accept, and we can see the plates here, and I can click on done. Now the next thing that I'm going to do, again, we could take the path of drawing an extra solid box and then discretize it, generating a mesh for that extra solid box. Instead, I'm going to follow a different path. I'm just going to copy the assemblage of elements that I have created, this blue assemblage that I've created for the bottom plate, and create a single copy of it at the top plate, which must be at a vertical distance of what? 12 inches the cylinder height plus 2 inches the thickness of the plate. It must be copied along a distance of 14 inches in the Z direction. Okay, first of all, what I want to do is I want to ensure that when I select nodes or elements, I won't mistakenly be able to select nodes or elements that belong to the cylinder part. To hide or show different parts from the view, what you have to do is you keep the model and part group of commands active, and you find the topmost button, the assembly and select part button. Okay, and here you have various options. You see both of my parts are selected at this point, meaning both of them are visible. If I left click on one of the parts, like the cylinder, I can now only have the elements and nodes of that first part being visible in the model. If I left click on the plates part, I can only see the elements or nodes of the plate, the second part that I have defined in my model. If I click on all, I can once again select and see all the nodes and elements of all the parts in my model. If I click on none, I automatically deselect and hide all the parts. Okay, once again, let's click on all. And then you may notice I have this checkbox with solid. I mean, if I have multiple parts with different types of elements like solids, shells, beams in the same model, I can click on the individual checkboxes and only select to show specific type of elements throughout the mesh. Just show the solid elements or just show the shell elements in a model. Okay, once again, what I'm going to do here is only select the plates part so that I hide the solid elements from the view. I can click on done. Another way to hide specific elements from view is to go in this button, the element tools, and find the blank option. This allows you to once again select elements by clicking on the pick command and then individually clicking on elements that you want. So notice I can click some elements. You can go on the area part and draw a window where you click and hide specific elements. You see you have the option to blank all or unblank all. And this applies only for whatever parts I have visible at any instant in time. For the time being, because we want to hide, we want to only keep visible all the elements of a particular specific part, it's much more straightforward to do it through the model and then the assembly and select part option. Okay, now how do I create the copy of all these elements for the bottom plate so that I have another copy for the top plate? You go first of all to this button, the element tools, which involves all the edit commands, and find this button, the transform button. The transform button is everything that allows you to translate a chunk of the mesh, move all the elements and nodes at a new position, or create copies, one or multiple copies of nodes or elements, or even rotate the elements and nodes of that you select about a particular axis. Once again, I let you experiment with this. For the time being, I just click on it and I will leave the transform option. That interests me is the translate option. The direction is along the Z direction because we want to translate nodes and elements along the positive Z axis. The distance, as I already mentioned, is 14 inches. And then make sure you activate this checkbox, the copy elements box, which means not whatever translation you will apply to the selected elements, you will create a copy which is translated by this particular distance that I define here. The number of copies, I set it equal to 1, so you could have multiple copies repeated at the same spacing here. That's the idea. And notice I also have the select nodes window here, where again you can activate the pick option and left click on individual nodes. Here we just want the area option so that we drag, okay, a window that selects all the nodes that correspond to the second part, the bottom plate part that we have defined. So all that remains for me is click on the translate in the positive direction. If you click on translate in the negative direction, this would be copied in the minus 14Z direction. So if I click on translate plus, I should be able to see, let's call it the candidate copy that is going to be created, which is exactly looking like what I actually need to have here. So once again, if I made a mistake somewhere and this was visibly, something was visibly wrong with what I intended to do, you could have clicked the reject the operation button and start all over. Right now, this is exactly what I need so that I can click the accept button. Then on done, lo and behold, I can go back to my model and part button, go to the assembly and select part command, and if I click on all, I should be able to now see, then done, I should be able to see my entire model. Okay, now if you hold down the control button on your keyboard and also hold down the left mouse button and then move your mouse, you can actually rotate the view in LS-PrePost in this manual fashion. Okay, so if I do this, I can actually see, I can also go then again to these preset views and go, let's say, to the front view, where this clearly seems to be what I actually need to have. What I'm going to create next is actually a set of 6 nodal sets. Okay, a set of sets, note this one, okay. So I'm going to create a set of nodes, all the nodes that are at the bottom of the bottom plate. These are the nodes on which we will apply full fixity to denote the fully fixed support. Then we will have a set for the top of the top plate, the nodes at the top of the top plate, which are the nodes where we will apply this downward displacement, this monotonically increasing downward displacement up to a value of 0.1 inch. And then we also need to create nodal set, two nodal sets, one for the nodes that belong on this face for the bottom plate, and one for the nodes that belong to this face for the bottom face of the cylinder. The reason is, you may already have noticed that there is a discrepancy in the discretization of the cylinder and the plates, the way I've done it. So what we are going to enforce is tie constraints, as we call them, between the nodes at the faces of the cylinder and the nodes at the faces of the plate. So this ensures we do have continuity of the displacements and the two pieces are treated as properly connected. If we don't do this, of course, the plates will just move as if they don't perceive the presence of the cylinder, which of course, it's like the cylinder floats in space, which of course isn't what we need. So let us begin by defining these nodal sets. Okay, I'm going to go to this view again because it's easier to see the various nodes this way. And once again, what I'm going to do first is go to the assembly and select part and keep only the plates active so that I can assign the sets for the plates first of all. So then to create entities like sets, you have to go to this button here, the create entity button. And in the entity creation dialog, go to the very bottom of this tree, the set data option, and find this command, the set node. Create a set of nodes basically. Left click on it, and then you can give, okay, the set ID. Notice I have this show preset where by default it shows the specific nodal sets that I've already created. Here I haven't created anything, so I have to select the create a new set radio button here. And notice I have the select nodes dialog showing up, and I can also give the name of the nodal set. Let's call it bottom, so we know this is the bottommost face of the model. It's actually the bottom of the bottom plate. And of course, to select nodes, once again, you can activate the pick command if you want to individually left click and pick on nodes. Here I'll just click on the area command, where once again I can, by the way, you have to hold down the left click button of your mouse to be able to drag this window. You select the nodes. You may notice the select nodes dialog lists the number of nodes that I have selected, which is 100. And if you click on apply now, I should be able to see that I created the first nodal set, which is named bottom, and it has a total of 100 nodes. Let me now create a second set at the topmost face of the entire model. I'll just call it top. Okay, and you can even give more informative name like top prescribed displacement, so that I know this is the nodal set on which we will be applying the prescribed displacement. And once again, we have to select nodes. By default, the select node starts from scratch. We don't have any of the previously selected nodes active right now. So once again, I'm going to select through a window all the nodes at the top of the top face, at the top face of the top plate of the model, and click on apply. Okay. Then I'm going to create a third nodal set by, let's call it top bottom plate. So this is the top face of the bottom plate. I need this again for one of the two tie constraints at the bottom of the cylinder that we have to define. These are the nodes on which we will actually assign to node set with ID 3. And let's click on apply. Okay, and the fourth and final nodal set that corresponds to the plates, I'm going to call it bottom top plate. And as you may be guessing, it's actually the nodes at the bottom face of the top plate, which will be used for the second tie constraint at the top face of the cylinder. And click on apply. Okay. And I can click on done. By the way, you can now go back to show, and by left clicking here, you can also in the meantime also play with the view. So actually you can see when you left click, in this list, you see different nodal sets highlighted. You can select many of them through the all command, or then you can go to none. You can hold down the shift button, okay, and then basically select multiple sets if you so wish. You can hold down the control button so you can select individual parts. The shift act, if I hold down the shift button and I click on 3, it selects other sets as well. Anyway, you can play with these commands right now. And if you show a particular set, you can even go to the modify button here, and then all the shown sets are the ones that which you can modify. So if I click on here, for instance, you can change the name and call it bottom dash fixed, so that we know this is the fixed bottom face of the entire model, and then click on apply and then on done. Okay, notice when I close this, I still see visible nodes from the set I had selected. You can always go back to the entity creation, make sure you activate the set node, then find the show radio button, and you see this bottom set is actually selected. You can click on none, and all of them are deselected. Now what I'm going to do is create the other two nodal sets, the nodes at the bottom face of the cylinder and the nodes at the top face of the cylinder. So what I'm doing first is go to the assembly and select part, and now I show the cylinder. Click on done. And then what I'm going to do is once again make the view to be from the front face of the model. And now I'm going to entity creation or create entity. We go to create set node, find the create radio button, and I'm going to call this cylinder dash bottom and select the nodes at the bottom face of this cylinder. Click on apply. Then the sixth and final set is will be called cylinder dash top. And of course we have to assign all the nodes on the top face of the cylinder, and click on apply and then done. And we can also go back to our beloved isometric view. We can go to the assembly and select part and click on all, and we can see our entire model. Again, we can find the auto center zoom button, and it might be prudent at this point to actually save our keyword file, because now that we have our mesh, it's always good to save something. I mean, every once in a while, I would say statistically it's 1 out of 50 to encounter some kind of glitch or bug in LS-PrePost, which oftentimes means your model creation process crashes. So it's always good practice to save your model regularly. Make sure you don't lose everything, as would have been the case for me, by the way, if something went wrong with my LS-PrePost here. And there are two ways to save a model in LS-PrePost. If you go to File, and you see you have Save, and then you have two options. Save keyword, where you save only the mesh information and all the information that applies to a finite element analysis. This is what we need to save and later read with FEMultiPhys from LS-PrePost input. But you can also save an LS-PrePost project. An LS-PrePost project saves the mesh, but also all the other secondary information, like the geometric entities. Again, to be able to load something in FEMultiPhys, you must eventually save a keyword file with all the definitions that we want to have, like nodes, elements, part IDs assigned to the elements, nodal sets, and also boundary conditions, as I'm going to show later on, and also curve definitions. It's always best practice if you use LS-PrePost to define the curves through LS-PrePost. By the way, you are strongly advised to take a look at the PDF user's manual. It should be provided with a link in the zeroth tutorial, the one that had to do with the installation. This user manual, and I can actually showcase here if I find it on my computer, if you just Give me one moment. So I'm going to my file explorer and I'm going to try and find my manual. I'll show you why I want to bring this forth. Okay, so yeah, this is it. The FEMultiPhys user manual. There is an appendix C in this manual which actually tells us what are the LS-PrePost keywords read by FEMultiPhys. Okay, so these are what parts of an input keyword file of LS-PrePost can be read, and believe it, everything that's on this single page suffices for every model you want to define through FEMultiPhys. By the way, these keywords are basically what information is written in the keyword file. The keyword file again is an ASCII text file of sorts which has all the input organization of LS-PrePost. So this particular keyword is tailored to the LS-DYNA solver, but parts of it we can read through FEMultiPhys. That's the general idea. So you can see the keywords that you have created up to this point by going to this keyword manager button. Again, it's in the model and part group of commands. So if I click on keyword manager, I should be able to see what I have defined. So right now we have defined 3660 element keyword lines, where you can see each one of these lines is actually the definition of the connectivity of a particular element. We also have 4,500 node keyword entries, which, as you may be imagining, they give us the coordinates of each one of our 4,500 nodes. We have the parts and the set. Okay, so let me actually save this model, and I'm going to save it. So I go to File, Save As. I'm going to save keyword as, and I'm going to find in my local drive here. Let me go to new. I'm going to create a new folder, and I'm going to call it tutorial concrete cylinder. Okay, I'm going to enter this folder here, and I'm going to name my file cylinder.k. So you always want to have a .k extension. You don't need the extension, strictly speaking, but it's prudent to have it because then by default you should be able to understand this is an LS-PrePost input file if you encounter one in your hard drive. So I click on save, and then again you click on save, and you should be able to see that model created in your drive. Before completing this first part of the tutorial, because we've dragged for a while, again, introducing LS-PrePost was meant to be kind of a drag. So I'm going to now, first of all, define the curve. Okay, the curve again gives me a function of time, basically. So I'll define a curve which gives us a monotonically increasing function of time, which function is equal to 0 at time 0 and 1 at time 1. This will allow us to run an analysis up to a time of 1 where we monotonically increase the magnitude of displacement from 0 to a target value. Okay, which won't be 1, but we'll see how we will do that. So to define a curve, you have to do it through the keyword manager. So click here, keyword manager, and notice by default the keyword manager has this model option active. This means this shows only the keywords that are already present in our model. I'm going to click this button, the all keywords, and notice there is this keyword tree of sorts. The keyword that we are looking for, we want to define a curve. So what we should be looking for is the define branch of commands, which if you expand, there should be an option which says curve. Okay, here. So then double click on it, and you should be able to see this dialog where you define a keyword input for LS-PrePost. So this is a define curve input form, basically. And you can give a title, which is always prudent because you know, when you have multiple curves defined, this allows you to see, having assigned titles to the curves allows you to understand what's the purpose of each curve. Let's just call it monotonic, okay? And you can give load curve ID, you can start with 1, or you can just click on add, and you have the lowest value of available ID at the cost of having to retype the title. No big deal here. Monotonic. So you should always click on add before you give the title. And notice here we have to enter basically pairs of x and y values. You can also load xy data by creating a txt file with pairs of x and y values, one pair in each line, and then the very first line of the file should be given how many pairs of values you have. So if you have 100 pairs of x and y values, the very first line of this file should be 100, so that LS-PrePost, when you click here on load XY data, okay, and you try to open a file, you should be able to see, okay, where is it that, I would want to actually find a particular, where in my local drive would I want to load a txt ASCII file from. For the time being, again, all we want to load is, okay, at time 0 we have a curve value of 0. So I can click on insert, and I have the very first point registered with my curve. At x equals 0, y is 0. Then I want at x equals 1, y must also be equal to 1. So I give a value of 1. By the way, A and O stand for abscissa and ordinate, which are the other ways of saying x coordinate and y coordinate of the points respectively. Okay, so if I click now on insert, I have a second point. Okay, then I can even have a final point at x equals 10, y is also equal to 1. So I can click on insert, and then to save this curve that I have defined with these three xy pairs, I need to click this accept button. This is similar to an apply button in other apps. And now I should be able to see in this list of defined curves the monotonic curve. Okay? The most beautiful part is you can even click now this plot button, and you should be able to see an XY plot of this curve. So I'm going to close this. If you wanted to add a second curve, well, let me do it now. We have a second curve. Let's call it cyclic curve. And you could have a cyclic curve which, okay, at x equals 0, y is 0. At x equals 1, 1.0, y is 1.0, insert. At x equals 3, y is minus 1.0. And then at x equals, I don't know, let's say 8, y is equal to, let's say, 2, and insert. Okay, and we can click on accept. We should be able to see this second cyclic curve, and if I click on plot, I see what should look like a cyclic curve, and I can click on close, and then done. Now if I bring it back the model only option, I now should be having the part of the model tree with the define and curve option. And if you want to edit your curve or add a new curve or whatever, you can just double click here, and you should be able to recover the list of curves. Go to the add button if you want to add the third curve, or select one of them, click on plot, and see how its curve looks like. Okay, so I click on done. All that remains is to define boundary conditions in this particular case. Okay, if I go to all, there are only two types of conditions that might interest me. So I can retract this define branch. I can also retract the element branch. The two types of conditions that interest me are load, if you want to apply forces at nodes or sets of nodes. It's not what we need to do here. And then it's also boundary, where we can apply boundary conditions like fixities for specific degrees of freedom, or apply prescribed motion, as we call it, where we apply prescribed displacement, or if we have dynamic analysis, we can also prescribe velocity or acceleration for selected nodes or sets of nodes. So let's begin with applying fixities. Fixities in LS-PrePost are also called single point constraints, and they are abbreviated through the acronym SPC. So if I go and expand this boundary and see these branches in alphabetic order, I'm looking for SPC and either SPC node, which means you can apply fixities at selected nodes, but what we are mainly interested in here is the SPC set option. So I double click on SPC set, so we will apply specific fixities or single point constraints at one set or multiple set of nodes. We can do it individually. I always like to assign an ID number. I click on add. Okay, nothing happens here. It's kind of a small glitch here. So I click one, I type 1 here, and the title is, okay, let's call it fixed bottom, so that I know this is the fixity that I apply on the bottom face. Here you have to give the ID of the nodal set, and if you click this neat button here, you should be able to see the list of nodal sets, and this is where the descriptive titles for your nodal sets help. Okay, I'm going to bottom fixed. This is the nodal set that we are looking for. Click on done, and then what we should do is, for each one of these 3 degrees of freedom, the translations in the X, Y, and Z direction, we change this binary flag from 0 to 1. 0 means the degrees of freedom are unrestrained. 1 means they are restrained. You don't worry about the rotational degrees of freedom here, because this is a solid model. The nodes of solids, you don't worry about the rotational degrees of freedom. They are not active anyway. So I can click on accept, and I should be able to see this first SPC defined. You could then click on add and define a second fixity for another nodal set if you so wish. We don't have anything else here, so we can click on done. And all that remains is define the prescribed displacement at the top face. So what I'm looking in the same boundary, let's call it set of branch commands, I'm looking for prescribed motion, and again you can apply prescribed motion at individual nodes. Here we are looking to apply a prescribed motion at a set of nodes. So I double click this prescribed motion set option, I click on add. Oh, again the same glitch, so I give an ID of 1. I don't think this ID matters. You could give ID of 0 at all of them. Let's give a title though. I mean, let's call it prescribed, or let's just call it downward displacement. And now we once again have to select which nodal set ID we want to apply this prescribed motion to. We give it at the node which has the set of nodes which has the proper name, top prescribed displacement. This is where we want to apply our displacement. Click on done. Then we have to select the degree of freedom. And a neat feature of FEMultiPhys is if you click these buttons, you may see some explanations. Okay. Here we want to select a value of 3, which is what would correspond to the Z translational degree of freedom for Cartesian systems. Then we have this VAD option, which if I click here, you see VAD stands for velocity acceleration displacement flag in LS-PrePost. So if this is 0, it means we prescribe a velocity. If it's 1, we prescribe an acceleration. If it's 2, we prescribe a displacement. So let us set it equal to 2. By the way, this is a nonlinear static analysis we will be running, so it didn't matter much. No matter what this VAD has assigned, it will be treated as a prescribed displacement for a static analysis. But I always find it good practice to have everything as properly defined and clearly defined as possible to avoid any misunderstandings. Then we have to give which load curve defines the dependence of the prescribed displacement with time. So that's where we can click here and select the curve that gives us the dependence of the prescribed displacement with time. So this is the first curve that we defined, which was 0 at time 0, 1 at time 1. And this is the load curve scale factor. This is the multiplier that we have to give, multiplying the values of the curve at each time instant to give us the actual displacement. And you may be guessing the value that I'm going to give for this load curve scale factor is minus 0.2. So that at time 1, the vertical displacement that I prescribe on this set of nodes will have a magnitude of 0.2, which was my target. Why the minus sign? Because minus 0.2 means it is in the negative z-axis direction. So it will be downwards with a magnitude of 0.2 inches. So make sure you click on accept so that you see this downward displacement definition registered in this list of defined prescribed motion sets that we have done. We have set keywords that we have established for this model. Then you can click on Done. And then you can activate the model radio button. And you can once again see now, okay, that all the options that we defined, this model is good to go as far as the pre-processing stage for LS-PrePost is concerned. So we can click on Done, and all that remains is go back to File, Save the keyword. So this should save our original keyword, okay? Let's say replace the original cylinder.k with the updated file that we have created. So this pretty much concludes this first part of this hopefully exciting tutorial. It was a bit slow, it took us a full hour, but the main reason for that was I wanted to take my time in showcasing some of the neat pre-processing stage features that LS-PrePost provides, which, trust me when I say it, they can be a lifesaver when you have more complex models, definitely much more complex models than this cylinder. But this cylinder as well, it is extremely much easier and safer, if I can use the term, to rely on LS-PrePost instead of my own lousy model editor, which, truth being told, hasn't been tested for some more challenging geometries. Okay, so hopefully this has been a helpful first part of this tutorial. See you soon we will continue rather with the second part, where we complete the part of the TXT input, and this will be done with the aid of the FEMultiPhys model editor app, of course.